Hello students, as we have discussed in our previous video about the various aspects of wind energy. We have discussed how can we produce the power through wind, and we got to know an idea about wind turbines. We have discussed how these wind turbines are working, how many types of wind turbines are there, and we have also covered the most important part, which is the energy calculations related to wind energy. We got to know the relation between the power and speed of the wind. So these are some important topics that we have already covered in our previous video, and now we'll move towards our next topic, which is design considerations for wind turbine. So talking about the design and dynamics part of wind turbine is very important. The efficiency of wind turbine depends on the design of each and every component that are involved in the wind turbine. So here we start with the turbine blades. The desired properties of turbine blades are they should be lightweight so that they can rotate easily. Their strength should be very high so that they can face a very high wind pressure. Fatigue resistance is also required as lot of stress variations and cyclic loading conditions are there throughout the whole rotation period of turbine blades. The last and important property is stiffness. The blade can maintain their shape during the rotation period and in extreme wind conditions. So these are some properties that are required for the designing and manufacturing of these turbine blades. Now moving towards the material selection. Generally, aluminium are used for the manufacturing of these turbine blades. But nowadays, people are also looking on some other alternatives such as composites. There's one more important aspect in the designing of these turbine blades, and which is environmental conditions. The blades can survive or operate in an efficient manner in a different environmental conditions is also very important, such as in extreme temperature conditions, in varying humidity, and several other environmental aspects in which turbine blades should work efficiently. So in this slide, we will discuss about the various designs of turbine blades. So generally, two types of designs are used in the windmills. The first one is lift design type and second is the drag design type. Lift design is generally used in the modern windmills. They have higher rotational speed, and these types of designs based on the same concept that is used in the aeroplane wings. As you can see in the figure, lower right side of the slide, the pressure below the wing is higher as compared to the pressure above the wing, and that is the reason that it pushes the wing to the upward direction. And the same concept is used by these types of mills, and that is the reason they are better suited for power generation. Their tip speed ratio, which we have discussed in the previous video, the ratio between the blade speed to the wind speed. So the tip speed ratio is higher or greater than 1 in these types of design. The second design type is drag design types. So these designs are traditionally used. They have greater torque but lower rotational speed, and they are better suited for the mechanical work. And of course, their tip speed ratio is less than 1. So apart from the turbine blades, there are several other important components that we will discuss in the further slides. So the next part or component of wind turbine is tower. Tower is one of the significant part of the whole setup. As taller the tower is, the more we get the energy, or we can say the rotational speed of the turbine blades. So if we increase or double the height of the tower, it also increases the wind speed by 10%. But this requires an increment in diameter of the tower by 4 times. Coming to the material part, concrete is generally used for its better life, as it provides the stability and rigidity to the structure, and better for taller towers. One of the challenge in this part is the construction of these taller towers and its associated cost. So moving towards some more important parts of wind turbine. One of the most important part is nacelle. Nacelle is something like a casing. As you can see in the figure also, it is just behind the turbine blades. And different components of wind turbines like gearbox, generator are incorporated into this single unit. Various mechanisms like braking mechanism and most importantly the yaw drive mechanism are handled by this unit. Yaw drive mechanism is responsible for the reorientation of the whole unit including the turbine blades in according to the wind direction. So this part is very much responsible for getting the higher efficiency of wind turbines. The next part is gearbox. So this unit connects the shaft from the blades to the generator. It is helpful in converting the low RPM of blades to the high RPM of generator. And the last one is generator. So this is responsible for converting the mechanical energy which we are getting through the rotor blade into the electrical energy. So these were the important parts that we have discussed. So at the end, we will discuss how much energy we can actually capture from the wind. There is a theoretical limit to the extent to which energy available in the wind can be captured. For this, there is a law called Patt's law, which provides the theoretical limit of capturing the energy from the wind. This law defines the ratio of wind velocity before it interacts with the turbine blade and the wind velocity after hitting the turbine blades. So this ratio provides us the efficiency, or we can say theoretical efficiency of the wind turbine. But in practical, we can only harness, or we can only get 10 to 30% of energy available in the wind. So with this, I want to end this topic. Thank you for listening.